Good morning, everyone, and a pleasant election day. Welcome to our subject, General Physics 2, with me, Teacher Kathy. So I was not able to inform you of your subject, particularly for the General Physics 2. So anyway, please know your subject, that this General Physics 2 is more of electricity and magnetism, optics, the basics of special relativity, atomic, and nuclear phenomena using the methods and concepts of algebra, geometry, trigonometry, graphical analysis, and basic calculus. That is the reason why one of your prerequisites to take General Physics 1 is the pre-calculus and basic calculus as the prerequisite subjects. And of course, for the General Physics 2, its prerequisite subject is the General Physics 1. And take note that this General Physics 2 is a specialized subject. And the grading system for this is still 40% comes from your written works and performance tasks, that is 60%. And this is the topic outline that our general physics 2 will be dealing with. So this is about the force and laws of motion, the power and energy, electric charge, the Coulomb's law, electric field and electric flux, electric potential, capacitance and the electrics, the current resistance and electromotive force, the direct circuits, current circuits, magnetic fields, the integration of electrostatic, magnetostatic, and electric circuits concepts, magnetic induction, light as an electromagnetic wave, geometric optics, interference and diffraction, relativity, and atomic, nuclear, and phenomena. And also do not forget to join the Kuiper class, my Kuiper class, and the Google Classroom for you Pythagoras. So as we begin with our new discussion, our new lesson for this General Physics 2, legend says that legend had it that the eminent scientist Sir Isaac Newton has hit on his head by an apple that fell from a tree. So, according to some historians, or according to some historians, that it was Isaac Newton, or there was a time wherein Isaac Newton was actually sitting under a tree, then an apple fell on his head, and thought that the responsible, as he observed the celestial bodies or the stars at the sky, he thought that the he thought that um the gravity is responsible, or the thing that is responsible for holding the celestial bodies in the sky are actually the same thing, or the same concept that is actually the reason why the apple fell on his head, and he termed it as gravity. So that was one of the legend stories about Isaac Newton. And this was far from true. However, and no written evidence has been published to support such an event. So that particular event that I've been telling you is just one of the product of the YouTube video that we watch, or that I've watched, and that was um an explanation of the apple that fell from the apple that fell to the head of Isaac Newton. But however, there was no written evidence that it was true. And instead, what was written is that the historical accounts about that, when Isaac Newton was actually returning to Cambridge due to a bubonic plague in 1667, he witnessed an apple fall from a tree while in an orchard. So while he was sitting maybe in an orchard, then an apple fall from a tree. So instead, this was the event that was um, written, not the apple that actually fell on his head. Bottom line is, whichever happens, whichever story is true about it, the bottom line is that this lesson begins the long yet a rewarding journey to explore the marvelous physics behind force and motion. So for this afternoon or for this morning, we are going to talk about the different types of force. Particularly, this is the types of forces. At the end of this lesson, you will be able to differentiate the contact and non-contact forces, distinguish also between mass and weight. Then we could also distinguish between contact and non-contact force. Let me begin the discussion by defining what is force. Force is simply defined as anything that an action and any action that has something to do with the push or the pull. So it is usually referred to as the pull or the push exerted upon an object as it interacts with another object. Please take note that force only exists when there are two objects that are interacting to each other. The other object is the one doing the push or the pull, and the other object or the second object is the object that is being pushed or being pulled. So force is a vector quantity. When we talk about the vector quantity, meaning it has a magnitude and direction. Since magnitude will tell us the magnitude will tell us the number, and the measurement or the unit, then it has a direction, which is moving forward, backwards, to the left, or to the right. So this vector F is distinguished according to its direction and its magnitude, or the amount of strength of the push or the pull. The magnitude of force is expressed by the SI unit Newton. So take note that the SI unit for force is known to be Newton with a single or with the small letter N, but its symbol is capital N. So when you write, when you were asked if what is the SI unit for Newton, and you just simply or you just write a capital letter N for Newton, then you are actually referring to Sir Isaac Newton, not the unit itself. So please be careful in the use of the small letter and capital letters in terms of spelling out the SI unit for force. And the spring balance is used to measure the force. So this is a device that actually measure the force. So if this is the object, this is um, the lateral surface of the object or the box. Then from here up to the push or the after to the from here, from the line up to here, this is actually 30 degrees for a push, or I mean for a pull, and that is 10 newtons. This 10 newtons is evident here in the spring balance, as well as here. And this second picture is actually a push. So remember that force refers to the pusher, to the pull or push exerted upon an object as it interacts with another object. The SI unit for force is Newton, and 1 Newton is equivalent to 1 kilogram multiplied by meters per square seconds. This means that it will take 1 Newton to accelerate 1 kilogram at a rate of 1 meter per square second. So we have here a conversion factor given as 1 Newton is equal to 1 kilogram of meter per square seconds. So based on this conversion factor, we can actually derive the formula for force. So force is a vector quantity. The quantity, the physical quantity that has an SI unit of kilogram is mass, and the SI unit or the quantity that has an SI unit of meter per square seconds is actually about acceleration. So from this given conversion factor, we could say that the formula for force is equal to the mass of the object multiplied by its acceleration. So there are two types of forces, particularly the contact and the non-contact forces. So under these two types of or two major types of forces, there are also sub types of these that falls into this particular category. Now, let me begin discussing about contact forces. From the word itself, contact, meaning it has a direct physical contact between two objects that is caused by what is called a contact force. And there are three major types of contact forces: the normal force, the friction force, the tension force. So let me discuss one by one to you. So normal force refers to the force exerted upon an object by the surface with which it is in contact with. This force is perpendicular to the surface regardless of its angle. So take note, when we talk about surface, it is an any flat object. So in this case, the object and the push and the force that you have exerted upon that object is perpendicular to the surface. So for example, in this picture, this is the surface, this is the object, and you are lifting the object, or you are lifting the box, meaning this is the force of the action, or the action force, and the surface is in perpendicular. Thus, you are exerting a normal force. The same thing as well as here. This is the surface, this is the object, and you are somehow pulling it. Then it is perpendicular to the object. Then you are exerting a normal force. Friction force, on the other hand, is that the action or the action force is parallel to the surface, parallel to the surface. For example, this is the surface, this is the object. When you are going to drag or to lift the object is parallel, or the box is parallel to the surface. When that happens, you are actually exerting a friction force. This friction force is also present in terms of the pavement, for example, pavement and for example, the sole of your shoe. So when you are going to step, when you are taking a step, you are touching, you are in contact with the floor or in the pavement, and in that particular moment that you are starting to walk, the action force of the push of your walking, or yeah, the push of your walking is actually parallel to the pavement. Thus, you are exerting a friction force. Another physical contact or contact force is the tension force. So this force refers to the pulling force exerted upon an object by a cord it is attached to. So any object that you have a cord attaching to it is actually creating a tension force. This is called the tension force because there exists a force between the cord and the object that you are pulling for. You are pulling. That's why it is called tension force. So aside from the normal force, the friction force, and the tension force, there are also other kinds of contact forces. In that includes the air resistance force, the applied force, and the spring force. Let me discuss it one by one. When we talk about the air resistance force, meaning it is a force opposite the relative motion of the object as it moves through the air. So normally the gravity pulls you down, and when you are against on the direction of the pulling or the direction of going down, you have actually air resistance force. This is the same experience as when you are, for example, doing a zip line, or you are in a zip line. So the gravity always pulls you down, and for you to glide on the rope that is extended for your zip line, the other end should be at the lower portion, so that you are going to slide. So each time that you will be doing the zip line, it is a downward force. Your body as the object is going downward, but then the wind is you are facing the wind, or you are against the wind direction. That's why it's creating a force or a sound that you can hear because of the air resistance force. Because of the air resistance force, or the wind, or the motion of the object, the motion of the you are downwards in the zip line, but then the motion of the air is moving forward for your body or for your object. So that's why there is an air resistance force. But then another thing is that applied force. So any force that you applied over to an object by a person or another object is considered to be an applied force. Any action or any movement that involves the push or the pull, it is considered as you are exerting an applied force if you have a physical contact with the object. Then, last but not the least type of contact force is the spring force. So anything that you are compressing or stretching involves spring force. Anything that you are compressing or stretching involves spring force, or you are exerting a spring force. Then we also have non-contact forces. So from the word itself, non-contact, meaning it is a long range or action at a distance forces. These act between objects that are distant and separated by a vacant space. So some examples of magnetic force. Some examples include magnetic force, electric force, and gravitational force. For the magnetic force, we have the north pole and the south pole of the magnetic force. So when two magnets are being held together with the same sign, such as a positive and a positive, it will repel. This is also true when there are two magnets, the north or either the north or the south pole of the magnet. You bring it together, then for a negative body, it will also repel. But then when you go in together, the North Pole and the South Pole, for instance, then it will attract. So this is it will attract. So these are the some of the magnetic force, some of the non-contact force, particularly the magnetic force. So when this happens, the repulsion and attraction between these magnets, there exists a force such as a magnetic force. Then aside from magnetic force, we also have electric force. So this electric force is actually present to all of your electrical devices that we have, this is an electric force is considered to be a force because of the moving charges, particularly the electron that is traveling in the wire. So later on our discussion for the general physics 2, I'll be discussing why does the negatively charged particle or the electron is moving from one place to another, or moving from one object to another object. So later on with our lesson, we will be discussing more of those. Then we also have from the non-contact forces as the gravitational force, or sometimes called as gravity. So when you use the word gravity, just use the one word as gravity. But if you wanted to use gravitational force, then that's okay. But never use the word gravity force because it would be redundant. Because gravity as the word or a single word is considered to be a force already. But when you add it as a gravity force, then it is already that is already redundant. So you just simply say gravity or simply say gravitational force. So this refers to the force responsible for attracting two objects that have mass or amount of matter available in an object. So gravity exists because there is an attraction between two objects that have mass, such as the mass of the moon against to any object that is being compared to the mass of the moon, and that is responsible of the what we call the gravitational force. And there are also all the known fundamental forces found in nature are field or non-contact forces. There is this also a strong nuclear force that keeps the atom from separating together due to the electric force from the repulsion of the protons. So the two or the protons or the subatomic particles are being together or merged together because of a strong nuclear force. Because if there is no such thing as a strong nuclear force, it will actually separate. But the atom that keeps them held together is a strong nuclear force. And the electromagnetic forces between electric charges can either be attractive or repulsive. It explains the interaction between moving and static charges. They also act at extremely large distances. So this is somehow would also agree on the previous slides about the magnetic force, or explains the magnetic force movement as well. Then the weak nuclear force is found in radioactive processes. It is also responsible for the nuclear reactions that generate the sun's energy output. Okay, so strong nuclear by the way, strong nuclear force is responsible for holding or for keeping the atoms together. But when this nuclear force loses its energy, it becomes weaker, or it becomes yes, it becomes weaker, and it will most probably, or most likely, it will have a weak nuclear force. Because of having a weak nuclear force, they are going to disintegrate, they are going to separate, they are going to explode, and that is the responsible for the sun's energy output. And the gravitational force, as mentioned above, is the force responsible for attracting two objects with mass, the moon and the other object. In astronomical systems, it determines the motion of moons, planets, stars, and galaxies. It also affects the nature of time and space. That is why when you go to the outer space, as you can see in the movies, they are actually floating. When they are in the outer space, they are actually floating, because the pull of the gravity is different when you are here on the earth and outside of the earth. And also it affects the nature of time and space, the nature of time and space. So the more you are away from the moon, the higher the gravity of the pull that is pulling you downward. But the closer you are to the moon, the more tendency that you are floating. That's why people or astronauts in the outer space are actually floating, because they are somehow nearer to the moon compared to our location. So those are the things, or those are the types of forces that I've been discussing to you, and I hope that you have learned something. And in order for you to check your understanding on this, I want you to answer this somehow as you watch the video, or watch this recorded video lesson, and also this one. Identify whether each situation entails a contact or a non-contact force, and determine what type of contact or non-contact force is most apparent in the interaction of objects therein. So for example, a flower vase on a table. So it is considered to be a contact because the flower vase is in contact with a table. But what type of contact forces it would have? So it would actually have an applied force, because the flower vase would have a gravity that is pulling downward, and the table as well, as it's strong, it holds the table, would also push upward. So it would be an applied force. Then it could actually be a, yeah, applied force as the contact force. Next one, an apple falling from a tree. So as you can see, the apple is already falling from a tree, meaning there is no contact between them. So this is a non-contact force, particularly the reason why apple is falling from a tree, because of gravity. So in the non-contact force, we could write here gravitational force or gravity. And the slowing down a car by hitting on the brakes. So slowing down, hitting on the brakes, meaning to say there is a contact force that needs between these objects, between the hitting on the brakes and the person hitting on the brakes. And the type of non-contact force it actually portrays, it's the friction. It is the friction as you hit on the brakes. So this is to sum it up, force refers to the push or pull exerted upon an object as it interacts with another object, and the SI unit for force is Newton, and it is known to be or to have 1 kilogram meter per square seconds. An interaction that brings about a direct physical contact is called contact force. It might be a normal force, friction force, tension force, applied force, air resistance force, and the spring force. And for the non-contact force, we could have it is an act between objects that are distant and separated by a vacant space. This includes the magnetic force, the electric force, the gravitational force. It could also have the strong nuclear force and the weak nuclear force. Then mass refers to the amount of matter available in an object, and this is distinguished from weight, which is the gravitational force that Earth exerts upon an object. I forgot to mention the difference between the mass and the weight. So the mass is actually the amount of matter available in an object. But when this amount of matter is interacted or multiplied, or there is the exertion of gravity over that particular amount of matter, it actually refers now to the weight of the object or to the weight of the person. Now, to check further your understanding, I want you to answer this in your mind, or to practice for you to practice your thinking skills. If Earth's mass would be split in half, would your weight now remain the same? Justify your answer. If Earth's mass would be split in half, let's say the mass of the Earth, this is just a hypothetical number, this is not the actual number, this is just an example. Let's say the Earth's mass is 600 um 600 600 tons, or let's say six 6 million okay, let's have it 6,000 tons, the weight or the mass of the Earth, and it would be split in half, meaning from 6,000 it would be reduced into 3,000 tons, for example. The question is that, would your weight remain the same after this? What would be your weight when you have this particular, when the Earth's mass is this, and what would be your weight if the Earth's mass would be split in half? Would you still have the same weight, or will your weight be also in half? So I want you to answer this question for you to be challenged. So all of these things are taken from Quipper, and these are the resources from Quipper. And I want you, after watching this video, I want you to answer your activity in the Google Classroom for this lesson. So all the details of this particular lesson, or the details of the particular activity will be posted in the Google Classroom. And I just have here some of our reminders. And that would be all. Thank you, everyone. Stay safe and have a good day.